So we have a problem here. It says the angle of elevation of the top of a tree from a point on the ground 7.2 meters from the base of the tree is 38 degrees. So I think the first thing is to put our point on the ground. So I have to draw the horizontal ground first. So these are our points on the ground. And then this must be the tree. So let's just represent the tree there. So that is the tree from the ground. Okay. And then it says the angle of elevation of a tree. That means we are trying to look up onto the tree from a point on the ground. Okay, so let the point on the ground there be, let's call our point P. So we are at this point P trying to look up the tree, and they're saying that the angle of elevation is, that means the angle we need to elevate our line of sight in order to see the top of the tree is 38 degrees. So this angle here is 38 degrees. Okay, so remember it says from a point on the ground 7.2 meters from the base of the tree. So this right here is the base of the tree. So they're saying from that point to the base of the tree. So we have from this point, okay, that distance there is 7.2 meters. So we have 7.2 meters. So that's the distance from our point to the base of the tree. Okay, we're asked to calculate the height. So let's call it h. So this height here is what we're asked to calculate. This height here, so we're going to call it our h. Now to solve it, we're going to use our knowledge of the trig ratios. Don't forget. So you see that this our height, which we are asked to calculate now, is the opposite side. As you can see, is the one facing that angle there. So that's the opposite side. And then the distance apart is 7.2 meters. Of course, that's the adjacent side. So of course, remember there is always a right angle. The tree is at right angle to the horizontal floor, so that's the right angle triangle we have there. So you see that we have the opposite side and we have the adjacent side. So we're going to ask ourselves, which of the trig ratios, remember, I'll just write it out here, the SOHCAHTOA. So which of the trig ratios have the opposite and adjacent side? You see that would be the TOA there. So I'm going to use tan. Remember that T there is for tangent. So tan theta now is 38 degrees. So tan 38 degrees will be equal to the opposite side, which is h, over the adjacent side, which is 7.2 meters. So if we cross multiply, we're going to have that our height h is 7.2 meters times tan 38 degrees. So all we need to do now is to press with our calculator, or if you have your 4-figure table, you can look at the value of tan 38 in your 4-figure table. So our height would be 7.2 times tan 38, and if we do that, we're going to have 5.625 to another. But we are asked to correct to one decimal place. Don't forget, we are asked to correct to one decimal place. So one decimal place means we just want to have only one number after the decimal point. So that will be 6. After 6, we have 2. 2 is not up to 5, so we run 6 down. So the answer will just be 5.6 meters. So this is the height of the tree above the ground. Okay, let's just look at another question there. A man walks 120 meters up a hill which slopes at an angle of 30 degrees to the horizontal. So I would like for you to pause this video and attempt this question by yourself. So it's always good to do that. Okay, so the first one we're going to do is we're going to draw our horizontal ground there. So that's the horizontal ground. So the man walks up a hill, and the hill is a slopey hill, so it slopes at an angle of 30 degrees. So let this be our hill. So it's going to slope like this. That's why he can actually walk on it, because if it's not slopey, he can't walk. Imagine if the hill is just upright like this. There is no way he could walk up the hill. So that's what we have there. So of course, you see that they say that the slope is at an angle of what? 30 degrees. So this angle here is 30 degrees. And how high did the man walk up the slope, or rather the distance he covered walking through the slope is 120 meters. So we're just going to put it there, 120 meters. So we also calculate, correct to the nearest meter, the height through which he rises. So you see that the height through which he rises is the height from the horizontal to this point. So that's the point you have there. Remember, this a right angle. So that's what we're looking for. So we're looking for this height, which is also what? H. So we're going to ask ourselves, which of the trig ratios again? We have SOHCAHTOA. So you see that these trig ratios have a very wide range of applicability. So that's why it's a very important concept you need to know. So we're going to say which of the trig ratios have, okay, let's identify the sides first. So you see that this 120 will be the hypotenuse because it's the side facing the right angle, while the height through which it rises is the opposite side since it's facing the angle 30 degrees. So we're going to ask ourselves, which of the trig ratios have the opposite side and the hypotenuse? You see that will be our SO. So we're going to use sine. So I'm going to say sine of the angle, which is sine 30 degrees, is equal to the opposite side, which is h, over the hypotenuse side, which is 120 meter. So if you cross multiply, we have that the height through which it rises, h, is equal to 120 meter times sine 30 degrees. Now, sine 30 degrees is a special angle, so we don't even need the calculator for that. Sine 30 is always 0.5 or half. So we just have 120 meter times half, 1 over 2. So half of 120 is what? 60. So the height through which it rises is 60 meters. So these just basic questions on angle of elevation and depression. So it's very important for us to crawl before we walk. So we're going to solve more questions on angle of elevation that the difficulty level will be a little bit higher than this one, but it's better for you to start with this before we get to that point. So if you enjoyed the video and you found it interesting and educative at the same time, I'd like for you to share this video with your friends, like, comment, and do have a great day.